Lamps include light source, lamp seeds, and accessories. The function is to redistribute the luminous flux of the light source, improve the utilization rate of light, avoid glare, protect the light source, isolate and protect the electric light source in special environments such as humidity, corrosion, explosive, and flammable, and also have a certain decorative effect. It is divided into two categories: decorative lamps and functional lamps. Decorative lamps are mainly to beautify the environment and take proper care of efficiency. Functional lamps mainly meet the requirements of light efficiency and low glare and take into account the decorative effect. There are three light characteristics of luminaries: photometric curve, shading angle, and luminary efficiency. The luminous intensity distribution curve of light source or lamps in all directions in space are called photometric curves. Plotted on a plane in polar coordinates, each point on the photometric curve represents the luminous intensity of the luminary in light direction. Photometric curves are usually drawn with a luminous flux of 1000 lumi from a light source. When the luminous flux emitted by the actual light source is not 1000 lumi, the luminous intensity value found on the luminosity curve should be corrected and multiplied by the ratio of the luminous flux emitted by the actual light source to 1000 lumi. The shading angle refers to the angle between the line connecting the most end point of the light source and the light outlet of the lamp and the horizontal line. The complementary angle of the shading angle is the cutoff angle. When the human eye is looking straight, when the angle between the connection line between the lamp and the eye and the horizontal line is less than the shading angle, the human eye cannot see the light source. When the position of the lamp is raised so that the included angle is greater than the shading angle, although the human eye can be seen the light source, the degree of glare has been reduced. When the lampshade is a translucent material, even if there is a certain shading angle, the surface brightness still needs to be limited because the lampshade itself has a certain brightness. Since the landscape will absorb part of the luminous flux, the light source will absorb a small amount of reflected light, and the rest is the luminous flux projected by the lamp to the surrounding space. Therefore, the efficiency of the luminary is equal to the ratio of the total luminous flux phi emitted by the luminary to the total luminous flux phi q emitted by all light sources in the luminary. Luminary efficiency is also known as luminary light output ratio, which depends on the size of the lampshade opening and the light reflectance and light transmittance of the lampshade material. Next, let's do an exercise. As can be seen from the figure, there are two oblate ceiling lamps 5 meters apart, 4 meters away from the working surface, and the light source is a 100-watt incandescent lamp. The light distribution curve is given. Point P1 is directly below lamp 1, and point P2 is between the two in the middle of the lamp, ignoring the influence of reflected light. Find the illuminance at points P1 and P2. The idea of solving the problem is find the luminous intensity from the luminosity curve and use the relationship between the luminous intensity and the illuminance to solve. First, find the illuminance formed by each lamp at each point. Determine the angle I between the normal of the working surface and the light according to the parallelogram theorem. Check the luminosity curve from the angle I to obtain the illuminance intensity, and then determine the distance by the parallelogram theorem. R value is substituted into the relational expression to obtain the illuminance. Then find the sum of the illuminance formed by the two lamps at the same point. Finally, check the actual luminance flux according to the power of the light source and correct the contrast. First, find the illuminance at point P1. The normal line of point P1 is vertically upward, which coincides with the light of lamp 1. Therefore, the angle line of lamp 1 at point P1 is 0 degree. According to 0 degree, the illuminance intensity is equal to 130 candela, and R1 is 4 meter, and E1 is obtained equal to 8.125 lux. The angle I formed by the normal of the point P1 and the light of the lamp 2 is about 51 degrees, using the Pythagorean theorem. And the luminous intensity is 90 candela from the luminosity curve. R2 is the hypotenuse of the right triangle, and E2 is found to be equal to 1.381 lux. The luminous flux of a 100-watt incandescent lamp is found to be 1139 lumi, and the illuminance at point 1 is equal to 11.2 lux. Use the same method to find the illuminance of point 22, since point 22 is located in the middle of the two lamps. The illuminance formed by the two lamps at point 22 is the same, and one of them can be found. The tangent of the angle I between the normal of the point P2 and the light of the lamp is equal to 2.5 divided by 4, and the angle I is approximately equal to 32 degrees, and the luminous intensity is 110 candela by checking the luminosity curve. Finding E1 equals E2 equals 4.19 lux. Then E2 is equal to 9.9 lux. From the calculation results, it can be seen that the illuminance formed by two 100-watt incandescent lamps at the same point is very small, and the illuminance of point P1 directly below the lamp is a little larger than that of the point P2 next to it. How to improve the illuminance while saving power and reduce the number of light sources? Can the purpose be achieved through the lamps and their arrangement? Next, let's take a look at types of the lamps. Lamps are divided into the following 5 categories according to the distribution of luminous flux in the upper and lower hemisphere: direct type, semi-direct type, diffuse type, semi-indirect type, and indirect type. Direct type lamps emit 90% to 100% of the direct luminous flux downward, and are made of opaque materials with good reflective performance, which should almost all the light downward. Semi-direct lamps emit 60% to 90% of the direct luminous flux downward, and use translucent materials or slips on the upper part of the opaque lampshade. Diffused lamp emit 40% to 60% of direct luminous flux downward, and are made of diffused transparent materials. Semi-indirect luminaries emit 10% to 40% direct luminous flux downward. The upper part of the luminary is made of transparent material or open, and the lower part is made of diffused transparent material. Indirect luminaries emit less than 10% of the direct luminous flux downward, and are made of opaque materials, sending almost all the light upward. This is the type of photometric curve of direct type lamps. According to the width of luminous flux distribution, it is divided into wide, uniform, cosine, and narrow. Among them, the maximum luminous intensity of the white type is distributed in the range of 50 to 90 degrees, which is suitable for square or road lighting. The narrow maximum luminous intensity distribution is in the range of 0 to 40 degrees, which is suitable for spaces with high floor heights. It can be seen from this that the selection of lamps need to consider the size of the room. The direct lighting characteristics are high efficiency of lamps, small influence of indoor surface reflection rate on illuminance, low investment, low maintenance, and use costs, but dark shading, large contrast between upper and lower brightness, and strong light directionality, resulting in heavy shadows. The lighting characteristics of semi-direct type, diffuse type, and semi-indirect type are: medium efficiency of lamps. medium influence on indoor surface reflection rate on luminance, medium investment, medium maintenance and use costs, soft indoor light, and relative uniform brightness distribution. The indirect lighting characteristics are all the light of the working surface comes from the reflected light. The lamp efficiency is low. The indoor surface reflection rate has great influence on the brightness. The investment is large, and the maintenance and use costs are high, but the indoor light is soft and uniform, and there is no glare. It can be seen from this that the selection of lamps needs to consider the light reflectance of the interior surface of the room and the working surface. The selection of lamps should also consider the environmental conditions of the lighting place, which should meet the following requirements. First, waterproof lamps with corresponding protective measures should be adopted in wet places. Second, closed lamp with corresponding anti-corrosion requirements should be used in places with corrosive gas or steam. Third, lamps with good heat dissipation and high temperature resistance should be used in high temperature places. Fourth, lamps in dust-polluted places should meet the requirements of dust-proof grade. Fifth, lamps in outdoor places should meet the requirements of waterproof grade. Sixth, there should be anti-vibration and anti-shading measures in places with large vibration and swing. Seventh, places that are vulnerable to mechanical damage and the light source may fall off by themselves, which may cause personal injury or property loss, should have protective measures. Eighth, places with explosion or fire hazard should comply with fire protection regulations. Ninth, for places with cleanliness requirements, clean lamps that are not easy to accumulate dust and easy to wipe should be used. 10th, for places that need to be protected from ultraviolet radiation, UV blocking lamps or non-ultraviolet light source should be used. Ballast for gas discharge lamps must also comply with relative regulations. According to the above content, you must have a solution to using lamps to improve the illuminance. Then, how to arrange lamps to get the design effect we need? Can lighting we need for certain room functions?